Good morning, everybody. Good afternoon. Good evening, depending on your time zone. Uh, this is Andre Bastos with InduSoft, and I would like to welcome you all to this week's webinar where we're going to talk about one of my favorite topics, which is the driver configuration. We're going to be talking about configuring the communication drivers, some hints, some tips, how to reach the best possible performance and communication using InduSoft Web Studio built-in communication drivers. This is our agenda for today. We're gonna talk a little bit about the company, some of the things about the product, and then we're gonna focus on the communication drivers module. We're gonna explain a little bit how we can optimize the communication, when we should use this or that other way of configuring the driver, and also troubleshooting it, a couple of hints that we learn with the experience. We're gonna use mostly the drivers from Allen Bradley and Siemens, and of course some of Modbus. But if during the webinar you post your questions on the Q&A, we may try to approach some other specific communication driver if time allows, and if of course I have the device available here in our lab. Alright, so let's get started just talking a little bit about the company InduSoft. We were established here in the United States in 1997. We were the very first company to come up with an entire complete product that was available for the Microsoft embedded operating system called Windows CE, and that was back in 1997. Windows CE version 1 it first came out, and that allowed us to start running on several different hardwares. And we have a web solution also since 1999, and we have our own patent for the database connectivity. You can use Windows CE devices to connect to any relational database. That means Oracle, that means SQL. Through our gateway, we have a patent on it. Here you can see some of the certification that we have. We are ISO 9001 certified company. We are a member of the OPC Foundation since its inception, and we've been winning several awards lately. Control engineering, as you can see, it's been 3 years in a row. So we are about to receive the notification about 2012 and 2013, and Frost Sullivan 2010 here. So that shows is a very solid company that has been recognized by its users. The Control Engineering award is by the readers of Control Engineering. They vote on us, so that shows how solid this company and this product is. So some of the main advantages of InduSoft Web Studio, we do have for data acquisition more than 240 built-in communication drivers. Okay, and we're gonna talk about this specific topic today. And but we also provide all the flavors of OPC communication. That means DA, UA, even OPC.NET client. We have that built in on the product, and doesn't matter what's your media, if it's gonna be wired or wireless. The driver is gonna be transparent for that, and we support several different physical layers. That means serial, Ethernet, or any other industrial bus. And for the graphic visualization, we support all the different Microsoft operating system. That's what we mean with the multi-platform. That supports also mobile devices, so you can have clients on Androids, on iPhones, on Microsoft Windows 8, Runtime. And then we have also linked symbols, which is a quite powerful tool for repetitive screens. You create a symbol just once, and then you can reuse it, and if you need to modify, just modify the master symbol. The modification will be applied throughout your project. And as background tasks, we can run as a service or as an application. So run as a service can be very interesting for data acquisition. So if you have a project and you're gonna have the communication driver acquiring data, you're gonna build trend charts, you're gonna have thin clients, you don't even need to log on the computer. You can configure InduSoft to run as a service. Okay, and then use thin clients, web thin clients to connect to that service. Built-in alarm management system and built-in trend, both the object to display the trend information as well as the trend saving historical information either on our proprietary format or on databases, event logger, and the interface to any SQL database. So that means SQL Server. We've been already testing SQL Server 2012, Oracle, MySQL, all those different database out there. A built-in security system with support to connect to Active Directory through LDAP, or just standalone security system, built-in recipes and reports module, and remote management, which means you can have the engineering in one machine and have the runtime in a different machine, and can download your modification directly to these other machines. Okay, so we run on any Windows operating system, and now we include also Windows 8. We've been having Windows 8 beta for a year now, and we've been testing it. Everything's been working. On our upcoming service pack, we're gonna have the enhancements to include multi-touch. The service pack's about 1 week away to be released, and then you're gonna be able to take advantage of the multi-touch capabilities that already had on Windows 7, but is way more present now on Windows 8 applications. And InduSoft gives you the power to use just one development environment in any Windows operating system, but the runtime you can run on either a desktop operating system or one of Microsoft embedded and mobile operating systems. So which means you can be creating a project that you're gonna run originally on a Windows CE, on an ARM-based processor, Windows CE 5, and then that project grows. You want to change your hardware, you're going to go into a Atom or x86 based processor. You don't need to change anything in your project. You just download to the new hardware, or you can scale it up to a more let's say to a bigger hardware with more memory, everything, and then you're gonna go into Windows Embedded Standard, which is Windows Embedded based on 7, and you can also build a big SCADA OEE system running on any Windows server, including Windows Server 2012. And one thing that we are very proud of is your investment protection. As you create a project on any version of InduSoft Web Studio, it runs to this day to our latest version. So we are currently on our version 7.1, and a project I created back in 1996 or 1997 that was InduSoft 2 or InduSoft 1.7, I still run on the latest version 7.1. We open the project just like we are opening any other project. There's no import or no tool required to convert to the newer version. We do this automatically. And as a deployment option with InduSoft Web Studio, you can have runtimes running on Windows Server operating systems, or you can have them running on headless mobile devices. You can have a control room with let's say bigger data acquisition projects, or local panel HMIs. You have a machine, you want to have an operator interface there, you can run InduSoft there as well. And as visualization options, you can connect to any of these runtimes, including a runtime running on a cloud computer or on a cloud system. You can have webcam clients on Internet Explorer, or you can have our secure viewers, which is our visualization module. So you have all the visualization here. You don't need to install the entire runtime in any of those computers here, connecting to any of those runtime applications. Doesn't matter if it's on Windows CE like this, or on a bigger control room like this one here. And also our mobile access, is completely operating system independent. The mobile access allows you to see train information, alarm information, tag values, write to tags, acknowledge alarms, all this type of thing in iOS, in Android, in Windows 8 runtime, anywhere that supports HTML5. So now we're gonna go to the main topic of this webinar, which is the communication drivers. The communication driver module on InduSoft Web Studio is one specific task that communicates with the tags database, and from the tags database it goes to the other tasks here. So I have a PLC, I'm calling it a process controller, a communication channel that can be serial, can be Ethernet. So our communication driver would talk to the controller, to the PLC, to the let's say a multi-loop controller, and we're gonna refresh the tags database, and from the tags database we're gonna go to the other tasks. Usually the viewer or a remote secure viewer, that's gonna be through TCP/IP communications. So let's just talk a little bit about the different driver types, starting with the physical layers. Usually most of the drivers, they are either serial, or they are TCP/IP or UDP/IP over Ethernet, or specific APIs when the driver requires a specific layer. For instance, Profibus or device nets or any other specific bus from the industry. So starting with the physical layer differences. A serial communication channel, most of the PLCs until let's say 2006, when you were going to buy a PC, you would get a serial port, DB9 there that would speak RS-232. Nowadays it's very hard to find that, but most of the PLCs, they had RS-232 communication channel, and to this day they still support that. Most of the new PLCs, they come also with USB ports, but it's gonna take a while for RS-232 to just disappear. So it's still very popular to have adapters from USB to RS-232 for PCs, and several Windows CE HMIs, they come with RS-232 port. It's almost mandatory to be able to talk to PLCs, low-cost PLCs without Ethernet channels. You're gonna go through RS-232. Or more specifically, you could go with RS-422 or 485. The main difference between these two channels is RS-232. I'm going to talk about the differences a little bit ahead, but RS-232, you have a distance limitation. RS-422 or 485, you can go longer distances, and you can also have multi-drop, while RS-232 is point-to-point communications or USB communications. And here's a note: that channel that you're gonna use for communicating between the HMI and the PLC is gonna be dedicated for that specific communications. And that's a difference to the second physical layer, where say Ethernet. When you have your Ethernet port, you use that to browse the internet, you use that to send emails, you use that also to talk to PLCs. So the same physical channel, but with multiple different layers of communication. Or we have the option that, and these two, they use standard Windows APIs, Windows resources. We don't need to install anything on the PC to talk serial or Ethernet, okay? But we have the option to use third-party APIs when you want something more specific. For example, CAN. If you want to talk CAN, you will not be able to buy a computer, let's say AGP, Dell, Acer, Asus computers with CAN communications. So you're gonna get one from Peak, you're gonna get one from Hilscher, and then we're gonna go to those specific channels. For those guys, we have the specific drivers and the specific APIs. So we develop the driver for those specific APIs for these different channels. I'm sorry for the background noise here. I guess the guy is just passing. There you go. So discuss a little bit about the serial channel. When you talk about RS-232, you're gonna be point-to-point and short distance. Usually, if you're talking about meters, it's gonna be maybe about 30 meters or 90 feet, not more than that. But sometimes that's all you need. But you have also limitations on the speed communication. The max is gonna go is, let's say, 115 megabits per second. Most of those devices, they talk 19 to 100, things like this. It's still good depending on what you're gonna do. And keep in mind that when you're talking serial communication, we send messages to the PLC to read the different addresses, one message at a time. So let's say I'm gonna read the inputs from 1 to 64, and then I'm gonna read the inputs from 65 to 127, and then I'm gonna read the internal registries from 1000 to 1064, so on and so forth. So the communication happens synchronously, okay? And so if you have the need of talking to multiple devices, RS-232 is not an option. You've got to go through RS-422 or RS-485. One of the main differences is that instead of the layer using voltage for ones and zeros, like plus 12 or minus 12 volts, this one goes through current. And current, you can have a longer distance because the value is going to be the same on the beginning or on the end of the channel. And that supports multi-drop. So you have several PLCs on a Modbus network. This is going to be your option. Okay, as long, of course, as the protocol supports, configuring station fields that allowed you to go to different PLCs. And then we take a quick look on the Ethernet channel. Again, the physical port you can use for several things. I'm using here the serial, my Ethernet channel to talk to you guys. And at the same time, I'm already connected to the PLC, and I'm going to use this Ethernet channel to talk to my PLC using my communication driver as well. Okay? And for PLCs, a good thing when you have a PLC that supports Ethernet is that you can have several times multiple HMIs connecting to that same PLC. Instead of having a more dedicated channel. Most of the older PLCs, the Ethernet board was one add-on, was expensive, was sometimes as expensive as a new CPU. But nowadays, most of the PLCs, they come with a built-in Ethernet channel on it, supports a minimum of 8 connections, and some go up to 128 simultaneous connections on the PLC. It became something almost mandatory to have Ethernet connection to the PLC. Okay? And then we go to the last layer when we talk about some specific type of bus. I got here some examples like Profibus, ControlNet, DeviceNet. The ones that are most commonly used with InduSoft are actually DH Plus and Modbus Plus. And one of the reasons for that is that when we replace legacy systems, people, they want to replace their the Allen Bradley panel views or their Cutter Hammer panel mates that, let's say, used to speak Modbus Plus or used to speak DH Plus or Remote IO, this type of thing. You're gonna put their SST card, for example, or SA85. So those are not things that you have on any PC. So you're gonna need to connect either a USB port on it or a PCI card. Is a different hardware. You're gonna need to install the device driver for it on the operating system, configure the device driver. You're gonna test that communication, use the built-in tools that come with those boards. Once those things are working, we have the driver to talk to those APIs. The APIs, they go to the hardware level, and from the hardware level, they go to the networks. Okay? So to Profibus, ControlNet, DeviceNet, or CAN bus, we have drivers for Hilscher boards. For CAN, we also have for PEAK boards. For DH Plus, we have for SST, DH Plus and Remote IO cards. For Controller Link, we have the Auron driver that goes through the FINS gateway or the SysMac gateway. And for Modbus Plus, we use the MBX from Schneider to speak with that specific bus. So, a little bit about now. Once we connected the PLC, how am I going to exchange information with the PLC? How is going to be the data exchange? So that's when you talk about the logical layer. The word protocol that we have here is exactly what bytes I'm going to send to the PLC and how the PLC is going to respond to me. Most of the drivers, they use the concept of master and slave, which means the PLC has its communication channel open, waiting for requests from the slave. So when the HMI wants to know something from the PLC, we send a message to the PLC, and the PLC responds to us. Here we have a screenshot of, for instance, the scheme of a Modbus. We send the message, and we get we are the master, so we send the message to the PLC. The PLC is slave, waiting for the response, and then send that response back to the master driver. Okay, most of the drivers, they are based on the concept of having a header where you're gonna have, let's say, the station that they're going to communicate with, the instruction that you're going to send to the PLC. Let's say I want to read, I have a specific function for that. Let's say on Modbus is 03, I'm going to read multiple registers. And then the message, if I'm writing, what value I'm writing to the PLC, if I'm reading, how many registers I want to read, and usually an error check at the end where we get all those bytes that we sent. We do an operation, let's say usually a XOR among all the bytes. We generate a final byte or a final word of error check. So both the master and the slave, they need to calculate this error check to see if the message that was transmitted is consistent. Because sometimes you may lose bytes on the message. Mainly when you have some communications through radios, you have serial channels, and you're gonna go talk to one RTU that is remotely, let's say, is on the Gulf or is on a water station. You may lose bytes there. So to check the consistency of the message, you use the error check. Okay, on the slave side, as it receives the request, it prepares the answer as well, and that's what we call the RX. So you can configure, you can check here what we call the TX message. That's the message that we send, and the RX message is the message that the HMI receives from the device. Okay, so some factors that may have a big impact on the communication on the logical layer. First is the message size. Some of the most modern protocols, they support more bytes per message, but in the past it wasn't pretty much like that. So some of the protocols that are out there for a while, they have a limit of how many bytes or words they're going to exchange. Some of the very old PLCs, they support only, let's say, 32 words per communication. And some of the current PLCs, they support like 1,000 bytes per communication. And so every time we want to know what is on the PLC, we're going to prepare a message on the format that we showed on the previous slides and send those messages to the PLC. The PLC will prepare the answer and send it to me. And how much information is going to be on that message will depend on which protocol we are using. The more modern the protocol, the more bytes you have per message. And the less messages you exchange, the faster is your communication. Okay, so let's say that you have a Siemens PLC and you have the DB1, DB2, DB3, DB4. The protocol says that for each one of these DBs, you need to send a different message. So if you want to optimize your communication, you may put all the HMI communication just one specific DB. So we can send a message, just one message, and we can read 1,000 bytes on each DB per message. Okay, so knowing your protocol is going to be one of the ways that you have to optimize the communication between your HMI, your SCADA, and your PLC. All right, some other specific impacts. More and more we see PACs, programmable automation controllers, out there. We have control logics, we have most of the PLCs based on code sys, we have backup TwinCat, we have already the ARM CJ2 family and the NJ2, the Speak Ethernet IP. We have GE fan coming up with tag-based PLCs as well, the Siemens 71200. So more and more you see PLCs out there that instead of using the concept of memory address, you use a tag name on the PLC. And for those devices, depending on the protocol, you have different ways to communicate that. One example for the Rockwell control logics, compact logics, it uses the CIP protocol, and the size of the message you can exchange is fixed by the protocol. I can send 544 bytes, and I can receive only 493 bytes. So this impacts how many messages am I going to exchange depending on the name of my tags that I have on the PLC. The larger the name, the more bytes I'm using on my message only to put the name of the tag. Okay, so we are coming out with a newer version of the ABCIP driver, which is the one that talks to the control logics, where this may not be an issue anymore. We're gonna have other way much faster performance, because we're gonna send the name of the tag just once to the PLC, and after that we're gonna send we're gonna only communicate with IDs. That version is, let's say, on the oven baking, ready to come out any minute now. So still, one thing that we suggest is to use arrays, because you have only one tag name and several positions of the same array. So when you send a message for those devices that they use tag names, if you use arrays, we're just saying use this tag name and give me 100 positions of that tag name. So you are not using the bytes on the text message to pass names of variables. Okay, and when you talk about specific third-party APIs, we have, for example, the driver for Backoff Twincat, where we use the library from Backoff called ADS, which is an extremely fast library. It's one of the best performance you can get. So with that library, when we wrote the driver, we limited the driver of a max of 512 variables per message. But doesn't matter if you have real, if you have integer, if you have double integer, the performance is going to be really fast. For Omron, we have drivers that use either the fins or the newest Sysmac gateway. Is also a very good communication. We go through code sys with PLC handler. So on those, when you have specific third-party APIs, what we do is we're going to talk not to the PLCs, we're going to talk to the APIs only. So how the API is going to get the data from the PLC into our tags, then it's going to be up to each one of those manufacturers. For instance, Backoff, they're talking to the PLC and refreshing their database. So when I ask the value of one variable, they will not go to the PLC and bring this variable. No, they already have the value, they're going to send it to me. Okay? When you talk about the SST DH plus card, it's not exactly like that. We're gonna send a message for the card's gonna go to the PLC and bring the information for us. But again, that's an older protocol, and that was the best that could be done back in time. So depending on the protocol, you may have, of course, a better performance even when you're using a third-party API like this. And big advantage of using Ethernet-based drivers is the simultaneous requests. This is a big advantage over serial driver. Serial driver, for each message I send to the PLC, I need to wait until the message is finished, and then I'm gonna send a new message. And when I say new message, let's say I'm gonna talk to Allen Bradley PLCs, the older PLC 5 and Slick family. I want to read the N7, I want to read the B3, I want to read the timer T4. For each one of these guys, up to 64 of those addresses, I'm going to prepare a message, send the message, and then wait for the reply. And not you, user, like we, the driver. So we read the N7. After that, you're going to read the B3. After that, I'm going to read the inputs. Only after that, I'm going to read the timers. When you have an Ethernet-based driver, like we have with Allen Bradley ABTCP, or we have the control logics, we can send several messages at the same time, and the PLC is able to handle that and reply to us all these messages at the same time. So I don't need to wait until I'm done reading the N7 to read the B3. I'm going to send both messages at the same time. Okay? So the limitation here is going to be how many simultaneous connection the PLC supports. So if you're talking about, let's say, the S7-200 from Siemens, it supports a maximum of 8 connections. So if our driver is going to use the 8 connections, you may not be able to use the Step 7 micro WIN to go online with that PLC, because we are using all the connections already. So it's important for you also to know the limitations of your PLC, how many Ethernet simultaneous connection that supports. Okay, so this is mostly for TCP/IP based drivers. All right, UDP you may have some other issues, but on TCP this can improve a lot your communication, mainly when you have several addresses. You're talking, let's say, Modbus over TCP with several devices. We can open multiple connections and talk to the same PLC faster and talk to multiple PLCs at the same time, which is a limitation you don't have when you use serial channels. Alright, so let's take a look now on the ways that you can configure the InduSoft driver sheets. So we're going to talk about the differences between using a main driver sheet and the standard driver sheet. So on this point now, if you're familiar with InduSoft Web Studio already, you're going to know better than if you're not familiar what the difference is. So if that's the first time that you're seeing anything related to communication driver or InduSoft, we basically have two ways to configure how you're going to talk to the PLC. And the driver on InduSoft Web Studio, as I showed, is a separated module. So when you're configuring the tags database, you don't say if that tag is going to be one IO or not. When you go to the drivers module, as I'm going to show here, then I can configure a worksheet. Let's say I'm going to talk Siemens Ethernet. So I say that these tags here, they're going to go to this PLC on this specific address. When I created these tags, I didn't create them as IOs. Okay? And this is good because I have the modularity of, let's say this is a Siemens driver. I have this PLC, these tag names here. Well, I'm going to move into an Allen Bradley PLC now. I can just copy this and paste on an Allen Bradley worksheet. Okay? So this is one of the layer of abstractions that you have with InduSoft Web Studio. Alright, so here I'm showing an example of a main driver sheet. And here you see our standard driver sheet. So discussing the pros and cons of each one of them. First, the main driver sheet. Pros is a very simple configuration because you use the same syntax as you have on the PLC. Here we have some examples. If you're familiar with Siemens, you're familiar with how you configure the DB, how you're going to talk to the PLC on those specific addresses. Or let's say if you're talking Allen Bradley, so let's say N64 column 1, N7 column 0, you know, it's the same address that you use on the PLC. You don't need to worry about how we're gonna create the messages, so you just put the addresses there, and then the driver on the background is going to sort that out and start sending messages for the PLC. Okay, and to optimize the communication, you can configure when you're going to talk to that address. If it's going to be always, if it's going to be only when you have the driver running. So here I have the option of always, or you're going to have this screen, or you have the option for auto as well. So we have all these different possibilities. Okay, and you have to keep in mind that readings, they're going to happen in groups. So even though it's very easy to configure the main driver sheet, it's very easy to also badly configure it. Let's say if you're using a Siemens, you're going to talk to the DB1, DB3, DB10, DB15, and every time you're going to talk to one of these DBs, you're going to send a message. And the less messages, the better the communication. Okay, so when you're configuring your PLC program, we highly recommend that you keep in mind that you're going to talk to an HMI. So the addresses or the tag that you're going to use to talk to the HMI, keep them close, keep them together. Make one array on the control logics, or on Siemens, keep everything on the same DB or in the less DBs as possible. If you're talking about Modbus, you keep on the 40X or on the 0X closer the addresses. Okay, so some of the cons about the main driver sheet: we have a fixed scan rate for all the groups. Doesn't matter if some groups you want to read more often or less often. Let's say that your alarm tags, you want to read them all the time. Of course, if that's one alarm, you want to be able to display the message. You're going to use the same priority and same scan rate as, let's say, a temperature that will not change that much every second. So you're going to be reading all the alarms every 600 milliseconds and every temperature point every 6 seconds, every 600 milliseconds as well. Okay. Another thing is that on each row you need to configure the station field. And as you see on this example here, we have all these tags talking to the same PLCs, but each one of these rows I need to enter the station field. Okay. And for debugging, it's a little bit harder to identify when you have a faulty group. Let's say that on Siemens you configure a wrong DB. Instead of 5, you put here, let's say 51, and it's harder to find where the error is. Okay, why? When you use the standard driver sheet, you have only one station field, and you know which group is failing. Okay, but we have nowadays debugging tools that makes it a little bit easier to identify which group is the faulty one. Okay, and for writing operations, we only write one item at a time. So let's say that you're going to download a recipe with 200 parameters. Well, we're gonna send you the PLC one parameter at a time. So sometimes it may be quite painful, and you write only when the tag changes. You don't choose when, like I'm gonna write everybody. No, only the tags that changed, these are the ones that are gonna be written to the PLC. All right. So these are some of the cons and some of the pros of the main driver sheet. So let's take a look on the main driver sheet configuration. This is how it looks like. So you configure the tag on the tag name column. That will be the InduSoft tag name. The tag is the one that you're gonna put on your screen to animate an object, to animate let's say a rectangle with a bar graph, or to resize an object depending on the valve state, things like this. You enter the station field. Depending on the PLC, the syntax for the station field may be different. Some PLCs require only the IP address. Other requires that you enter the TCP/IP port number, or like in this case on the Siemens Ethernet, as part of the protocol, we need to pass the IP address, we need to pass the number of the backplane, or the rack number, and also the slot where the CPU is on the rack. Okay, when you talk about Allen Bradley ABC IP, I need to enter the IP address and also the slot number where the CPU is as part of the protocol. Okay, and then on the IO address column, we enter the PLC address itself, the register that I want to communicate with. So this syntax always changes depending on which PLC you're talking with. So here I have a Siemens PLC, so I'm talking to specific DBs, or I'm talking here to the memory byte 11.7. When you talk with Allen Bradley's, we may talk to specific bits. Then this, for instance, I'm going to talk here with a B3 0 bit 13 on Allen Bradley. So here's my PLC address, and my IO address is going to be B3:0/15, because on Allen Bradley, those older PLCs, you use slash for the bit address. So the same address that you use on the PLC, you're going to use on the IO address when you use the main driver sheet. Okay, so as a comparison here, I'm going to show another PLC that I have connected now. So this is a Cymatic Siemens step 7. I'm talking to a CPU S7 315. So here, if I open here my Siemens driver, if I want to talk, let's say, to the DB4, the B-Word 7, that's how I configure on the driver. And this is how I configure also on the Siemens software. So when I read this, I have here my value. I'm going to put here, let's say, in decimal. So I have this specific value. Let's say I'm going to write something easy to identify. So I write this on the PLC. So when I start talking to the PLC on this specific address, that's the value that I'm going to read. And it's very easy to configure because we use the exact same syntax both on the PLC and on the HMI. Okay? Alright, so back to the presentation here. And then you have the action. If you want to read, if you want to write only, if you want to read and write, you know, some addresses you may want to do both, some addresses you may want to read only. Okay, let's say that alarm tags, you're going to read only. You may configure to only read, and you have the configuration when you're going to read. If it's going to be always, alarm tag is going to read constantly, or only when you have that tag being displayed on a screen. Usually I get, as an example, a PID configuration. So you don't need to read the PID parameters all the time. But if you're going to adjust the PLC parameters as you open your PID specific screen, we can go and start communicating with the PID parameters. So that optimizes the communication. You'll not be talking to those addresses constantly. The less messages you send to the PLC, the faster is your communication. Okay, just keep in mind that sometimes, depending on the protocol, You may want to have scan as always for everybody. In other protocols, you may want to have only screen most of the time. And even tags that I want to write, we're going to write only when the tag changes. So you need to be careful when you do this type of configuration, because unless we know that the tag changed, we will not be able to write those things to the PLC. Alright, I usually use this for the start cycle to toggle tags on the PLC, or I set a flag on the PLC and the PLC program resets that flag. And then when I set it again, I use our force option on the command. We force that guy to 1 as well. We write it to the PLC. So discussing a little bit about the main driver sheet. When I have an error, okay, that's the hardest part on the main driver sheet. Configuring it is very simple, but when it's not working, that's when you're gonna start looking on your configuration. You're gonna call our tech support. Your best friend to debugging the communication is to use the output window. We also call the log win. So when you're talking to a remote device, you're going to use the log win, which is this window here, okay? Or the log win tool when I enter the IP address of my remote device. So if I'm talking to if I configuring, let's say, Windows CE project, I may need to be able to debug that communication by entering the IP address of my project, of the HMI that is running my project on Windows CE. I'm gonna see if I can configure a C here to remotely talk to me. Give me just a second here. All right. So I have a Windows C device here. Okay, now we can see it. So this I'm remote desktoping a Windows C device. So you can see here on the system that this is a Windows C 5. Okay, it's loading the system here. Okay, in the meantime, okay, here's the system. So it shows Windows C 5 is a Pentium HMI. So we can talk to this guy. I have the remote agent running. So I have here the IP address. So if I download this project to the Windows C device and enter this IP address here on my output window, I'll be able to debug the communication that is happening there as well. All right. So here's the output window. I configure here 3 communication drivers: the Allen Bradley, ABTCP. I'm talking also with a Modbus PLC here. You know, I misconfigured the address on purpose here. I'm gonna talk, for example, to another address that I know it works. So on Modbus, for instance, on the PLC, this is my address. Some other PLCs, you may have only 5 digits. Other PLCs, I have 6 digits for the address. So for us, we're gonna consider that you put this the number that defines what is that address type. You know, 3 for like 3000s for input reads, 4000s for read and write words, 0x for read and write bits, 1x for read-only bits. So here we have one address. I'm talking to this guy. I save it. Okay. So when you're debugging a driver, you don't need to run your entire project. You may here call tasks and run the driver only. So if you're configuring the driver, or if you think you're having communication issues, you can run the driver only. So I don't need to run the entire project. Okay. And here on the output window, I can, on the settings, choose what type of messages I want to see. So I have here few read commands. So it shows the message that I'm trying to read from the PLC. I'm gonna pause and I'm gonna analyze. So I know that the address for X1 is communicating well. These addresses from Siemens are communicating well, but this address on the ABTCP, I'm having an error. And then the error, according to the protocol, is address doesn't point to something usable. Well, that's the protocol documentation error for that specific error that we are receiving here. And that error usually means that I'm pointing to an N that doesn't exist on the PLC. So if I point to something that does exist, this communication should disappear. I know I have on my PLC my N7:1. If I save it, this error will no longer happen. So here I'm talking. So if I pause now, I can see it. See, the N7:1, I don't have a problem. Alright? So I have here illegal data address for the Modbus TCP. I'm trying to read this big address here that doesn't exist. So then I end up having this type of error. Okay? Or on the Siemens, we have a status that our API sends us saying that it's not communicating to the DB3. I don't have a DB3 on that PLC. So if I look here on my configuration, I have DB1, DB2, and then I skip to DB4. So if I try to talk to the DB3 as I have configured here, this is gonna fail. I don't have that DB. Okay, so I go ahead, I fix my error here. Oh, it's not DB3 that I want to talk to. It's actually DB4. So I don't even need to stop the driver to change that. Okay, I can keep communicating. On the Modbus, we see the error happening here. Oh no, I mistyped that. I don't need to talk to all that. I'm gonna talk to the 4x44. I change that, I save, and look, all my communication is okay now. Alright, so if I go and download the same project to the Windows CE device, I'm gonna connect to that Windows CE. I'm gonna connect. Here's my project. I'm going to download the project to the PLC. To the PLC, no, sorry, to the Windows CE HMI. So I'm downloading here. On this project, I don't have a screen, so we may not exactly see things there. I do have a license here. Okay, good. So I'm gonna run the project. So the runtime was started on the Windows CE device. So at this point, I can also go here on the login, enter the IP address of my Windows CE device, connect to it, and I can log the messages and the errors that are happening on my Windows CE device. So the same thing that we have on the output window, we have on Windows CE. And for tech support purposes, if you're having problems and our tech support people, they ask you to send us the log of the communication, you may come here on options and save on disk. So you're gonna save all the messages. Okay, you can be to a custom file, or we can use our standard file name. But for remote Windows CE, it's good to have a custom file name. So you enable that, you're gonna be talking to the PLC, and you're gonna send us this message or this file with all the messages. Okay, for tech support reasons, not only much for you to debugging, when you think you did everything and you still having communication issues, you may need our assistance. So we may ask you to send us the communication log. In that case, it's important that you come and you enable here on settings the protocol analyzer. With the protocol analyzer, look, we see all the bytes that we are exchanging with the PLC. For you, that may not be too important. For us, this is where we're gonna find where the problem is. So here you see, I'm gonna pause the TX and RX messages that we are exchanging with the PLC. TX are the messages we are sending, and RX are the messages we are receiving from the PLC. Okay, so we send the message, waiting for read, and we have the response from the PLC. So we got here saying that the communication was okay. We got here the RX saying the communication was okay. We have the IDs because we have multiple drivers talking at the same time. So we sent this TX. You have the ID 16A8, and then here is the RX, the response for that, and here's the message for that. The read item went fine. So we have to have this ID because in this case here, I'm running 3 different communication drivers. All right. So for you to debug the communication, you can use the database SPI, so you can see the values that you have on the PLC. So I can enable here. I copy from there, so I see here the values that are on the PLC. If I get my Siemens, I can select the entire column and paste everything on the database SPI. So I don't even need to create screens to go and see those values. I can use the database SPI to see the values that are on the PLC. So I see here my DB4, DB Word 7. It has the value 55. That's the value that I wrote here on the PLC. I'm gonna write a different value here. Let's say 1, 2, 3, 4. So I write this to the PLC. Ta-da! I see the value now on my tag. I didn't need to create a screen or display, because when you're configuring the communication part of your project, that usually where you spend most of your time, and where you may have more engineering, sometimes more issues. So these two tools here can really help you. The same way as we have the remote login, we have the remote database SPI. So same thing, I enter the IP address, and I'm gonna talk here. It saved some of the previous values. So if I put here my tag test, this is the value that I have on my Windows CE device. If I put here my tag temperature 1, see, that's the value that I have on my Windows CE device. So you can debug that as well. Alright, so moving forward, what other type of errors you may have? You may configure a wrong PLC station. You may configure wrong communication settings. When you're talking about Windows, when you're talking about serial drivers, let's say I'm gonna configure here the modBU communication driver. On the settings, I can configure if that communication is gonna be RTU or ASCII. If you're gonna choose the COM port, the baud rate, the parity. So you may misconfigure these guys, or you may misconfigure the handshake. You may use RTS by software instead of hardware, or you may configure wrong block size. Some I/O terminals out there, the block size to speak Modbus is only, let's say, 8 words. So you would configure here for 8. Other support 125 words. Okay, so depending on the communication you do here, you may have communication issues. All right, so look on this. You're gonna see most of the messages here. Of course, if you configure wrong COM port, as you try to open it, it's gonna fail. Or if the COM exists but you're not connected to that channel, we may timeout. Like timeout is we send a message, the PLC doesn't answer. Okay, if I misconfigure a station here, I also will not be able to connect to that PLC, so we're gonna have the message here that the connection failed. That's the first thing on an Ethernet communication, is to create the connection. All right, and the wrong PLC addresses, that the example that we were using here. More specifically, for tag-based PLC, we show which tag is failing. So let me remove some of the drivers here. I'm gonna put the driver ABCIP. Let me stop the communication, and here, this is stop command. I'm stopping the communication on the Windows C device. Now I'm gonna stop locally here. Let me delete everything here. So I'm gonna configure the driver ABCIP that talks to control logics. So I have here the IP address of my PLC, the station number, and let's say that I misconfigured the tag name. Like, I know that this tag here I don't have on the PLC. So I start the driver. So I'm gonna pause here, and here I have the message. PLC tag name, my double in tag 102, not found on the PLC. Oh, it's not 102, it's underscore 102. So I'm gonna unpause here. I have the error. I'm gonna save my worksheet, so I didn't even need to stop the driver, and all my communication is okay now. All right. So it's important to know this type of thing, because I have all these tags here. And then you see the quality good means that the values are properly coming from the PLC. If I misconfigure one address and one address only, this entire group is going to fail, because I'm sending a message to the PLC to read all these tags on the same message, and the PLC is going to say, "Uh-oh, you have a bad tag on your message," and that's enough for the PLC to say, "I'm not talking to you anymore," you know. But at least we say which tag is invalid. I fix that tag, save it. All the tags are good now. All right, so this is good also for TwinCat, for CodeSys. We're gonna always show which one is the invalid tag. And now the communication is good. All right, so enable the protocol analyzer to see which tag is invalid. Settings, protocol analyzer. All right. So some other ways to troubleshoot. When you have those communication drivers, I'm gonna put here again the Siemens driver, Siemens Ethernet communication driver here, and then when we start the runtime with those drivers, we create what, as you can see here, virtual groups for each one of these drivers. So for the Siemens, I'm saying that I'm reading the DB4, I'm reading the DB5. For the ABCIP, I have a group that goes from my int tag 1 to my int tag 2. Well, am I reading also the 10 and the 102? I don't have a way to know exactly here. Okay, so for more experienced users, it's important for you guys to know that you can edit the options section on your app file. So every project will always have the app file. So if I have here, I'm gonna go to this project folder. Here under project information, here's my project folder. So let me go there. I can open the app file using a text editor, let's say Notepad, and I'm gonna look for the options section, and I'm gonna enable this specific entry here, dump driver sheets. Okay, dump driver sheets equals 1. You save, you close that app file, run the project again. As you call the runtime, you're gonna find the driver files under the web dump folder. So if I go under web dump folder, here are DRV files. Those DRV files, I can open them. If I go here on the project and go here, actually here, open project file, I enter the path, and here I choose to open driver files. So here I can see which tags I have each one of these worksheets. So for instance, for the ABCIP, this is how we are constructing our messages. The first tag I'm passing is 1, the second is 10, the third is 103, the last is my double int tag 2. So this here, this right click, virtual read groups, may be misleading, thinking that you're talking only to 2 tags, when actually you're talking from 1 to the 2. Alright, so you have this way to see it if you enable the dump driver sheets under the options section on your app file. Alright, and the last hint for main driver worksheet users is if you want to change the reading rate. Let me stop here. I'm going to remove one of the drivers. Let's say I'm going to remove the Saif, keep only the Allen Bradley. And here on my settings, I'm going to enable date and time. And I'm going to start the driver again. And I'm going to disable the protocol analyzer. I'm going to see only the reads. So let me pause here. Actually, let me delete. got some messages, pause. So here you can see the timestamp of each one of the reading events. You're gonna see that there's a difference that is usually about 600 milliseconds. It's not precise, not real time, but you can see here that we go about 600 milliseconds. Okay, so here is almost 600 milliseconds. So why is that? What happens is the communication rate is based on an internal tag called blink slow. So if you see here the system tags, you're gonna find a tag called blink slow. The blink slow changes every 600 milliseconds. So whenever this tag changes, we're gonna read. Okay? If you wanna change that, again, you can open the app file using a text editor. You're gonna find again the options section, and then you're gonna create a specific entry called main drv always trigger, and put a new tag name there. So we have a system tag called blink fast that changes every 200 milliseconds. So you can simply type here blink fast, and you're gonna read much faster than we were before. So if I stop here, I'm gonna go edit that file. So I'm gonna find the options section. Here it is, and I'm gonna put here main drv. What's the name again? Main drv always trigger. Main drv always trigger, and I'm gonna put the internal tag called blink fast, the system tag. I save this. I may want to reload the project, so I'm gonna open again so we can read that information. Now as I start the communication driver, let me unpause here, enable field read and the date and time. I'm gonna pause, so you can see that the communications happen much faster now. It's close to 200 milliseconds depending on the available resource, but it's closer to 200 milliseconds. So we are banging the PLC much more for information. And to do that, on the main driver sheet, you open the app, find options, and enter this entry here. Alright, so we are passing 1 hour already, so I'm gonna need to rush a little bit about the standard driver sheet. The standard driver sheet, a good thing about the standard driver sheet is that you have full control of what's happening. A good thing is that you configure the station field just once. The bad thing is that you only have one type of address per worksheet, but you have the triggers and the enable read and the complete and the status for each one of these worksheets. So you can know when you finish writing something on this specific worksheet. You can decide when you're going to specifically read that. We're going to discuss that on this next slides here. So, pros: you have total control of your communication. You can read either as fast as possible or only on demand. You can write an entire group of variables in just one shot. You have the individual communication feedback if you have communication errors, and one station field, you communicate with the entire group differently than when you have the standard driver sheet. So if I go here on my drivers, I'm gonna put back the AB TCP driver. So here it is. Here's the main driver sheet. I need to configure the station for each one of the rows, but here I configure just one station for all the rows. But here I only talk to N7 colon 0. Here, no, I can talk to N7, I can talk to B3, everybody. Okay? And the cons are, the configuration is less user-friendly, less friendly than the main driver sheet, because again, you need to learn some things like what you put on the header fields, and on the address, you don't have the exact address that you have on the PLC. I don't put here, for instance, this. No, what we do is, I configure a header with the address type, and then the word or the bit, for example, On the Allen Bradley is the /7, the bit related to this specific address here. That's my start address on the case of the Allen Bradley. On the case of the Siemens, I would put here the DB and I start bytes for that specific DB, and then here the address related to that specific byte. So it's less friendly, but it gives you full control, you know. But each worksheet you're gonna have only one station, you're gonna have only one register type, and you may have to configure several worksheets for your communication depending on the size of your project. But if you have you need to have full control of your communication, we recommend using the more advanced standard driver sheets. A quick discussion about the fields on the driver sheet, those fields here. Okay, the enable read when idle. When you enable this field here, I'm gonna give you an example. I'm gonna make the enable read when idle for this worksheet 1. And I'm going to enable the communication now here. This is the fastest communication you can have. I'm going to pause. So we show here that the read group from the N7, we are reading almost every 30 milliseconds. Okay? That's how often we are sending messages to the PLC, every 30 milliseconds, when I use the enable read when idle. So that's the fastest communication you can have. But this has a lower priority than all the other operations. So if I do a read trigger with any driver, I'm going to execute the trigger and then go back into enable read when idle. If I do a write, I'm going to first write and then go back into reading. So if I enable here my write commands, I'm going to, for example, here do a write trigger to my PLC. So I'm going to toggle my trigger, boom. If I pause, there's too many communications happening, but I should be able to find somewhere here. Here, I wrote the group as soon as I changed the tag value. Okay, so it was here, so I finished reading and then I wrote right away. So this idle means that whenever I'm not writing or I'm not using the read trigger, that's when they're going to be reading as fast as possible. Okay, and the main driver sheet has a higher priority. So when you see here you don't have the read group number, that means like in this case you don't have the group number on the message. That means this group is from the main driver sheet. Otherwise you're gonna have the group number 1 would be the group number here on the driver worksheet. Alright, so when would you use the read trigger if I can have this fast communication? So let's say that you want to read a specific parameter. Let's say you're going to read your recipes. You're going to use the trigger, boom, you read everything that's on the PLC. You will not keep reading that. Okay? Or sometimes you're going to have a specific reading rate. You have something that you need to read every second. Okay, you put here on the read trigger the system tag second. Whenever the tag changes, we're going to read from the PLC that thing. Okay, so I use that usually to read a recipe or to read PID parameters, other stuff that you don't have to read constantly. Okay, it has a higher priority than enable read, and it shares the priority with the main driver sheet. Actually, the main driver sheet, when we create the groups, we use the tag that we configure there, or the blink slow, as a trigger. You know, that's what we do on the background. All right. So the write fields, we have 2 fields to decide when to write: a trigger and enable write on tag change. The main difference is the write trigger, whenever this tag here changes, I'm gonna write the entire worksheet. This is pretty good when you need to write several things in just one shot, as for example recipes. Okay, it has a higher priority than any read event, you know. That's the second one. But one important thing is that usually that doesn't work when you have bits, specific bits. It works with Allen Bradley, but not with all the drivers. Okay, and the enable write on tag change, when any of these tags here change the value, we write only that specific tag. So you may look the write trigger as write group and enable write on tag change as write item. Okay, so if I change the temperature to 3, that's the only one that I'm gonna write if I have this guy enabled. Okay, so when you have the trigger or the tag change in conjunction with the write completed and the write status, I'm gonna put here the write completed tag on the database PI. So if I use my write trigger, already entire worksheet, my write completed changes whenever I write something. So if I put here my temperature tags, here I have the values. I'm gonna enable write on tag change. So on my project I put 1, and then I'm gonna write specifically my temperature 2. As soon as I'm done writing, I have here the write completed changing and the status to tell me if that change was successful or not. So if I go here on my settings and enable only the write commands, whenever I write something, so I'm gonna write here, let's say 777, boom, I have the message that I wrote the item, the value is this, and it worked. Okay, so if I write the trigger, I change the value of my write trigger tag, I had a message that I wrote the entire group and the status was okay. Alright, so between InduSoft releases, we may update the communication drivers, we may release new functionalities, new versions with bug fixes and everything. So you don't need to update your entire InduSoft installation to update only a communication driver. Alright, you can go to our website. So you're gonna see the link support. Under the link support, you're gonna see latest drivers. Click on that link, you're gonna go to our drivers page. You're gonna find the link to download the driver. It's an executable file. It runs the install shield. So you download the file, you close Web Studio, it needs to be stopped. You run the setup program. Here I'm installing, for instance, the driver BACnet. So you just follow the next. When you have several installations of InduSoft, you choose which folder you want to install that to. Okay, and then we're gonna update that specific folder with the latest communication driver. And if you're talking with Windows CE, you may need to execute install system files. So here on InduSoft, I go on connect. I connect to my C device, and I click on install system files. This will update. When they have this option here, all in your files, this will update only the driver files on the Windows CE device. Alright? If you want to learn more about the drivers, you can see our online training that we have ready for that. So you can go to our webpage, InduSoft.com. Again, you go on support. Under support, you're going to find the link to videos and webinars. As you go there, you're going to see the free online video trainings for InduSoft Web Studio. And there you're going to see the modules 7 and 8. This talks about communication drivers. Okay, this is free. Everybody can see those trainings. Alright, InduSoft also offers in-depth training. So here on our website, if you go under the training page, you're going to see the dates that we have, and you can also customize the training on your facility. Just send an email to training@indusoft.com. And we're gonna go to the Q&A session now. You guys should have a Q&A frame there. You can open it and type your questions. Depending on the questions, I'm going to answer to everybody or some specific questions, okay? So I have a question here. Someone asking if I can discuss a driver that we have called TXRX driver. So quickly here, if I go to add remove drivers, you're gonna have a driver that we have called TXRX. This is a very specific driver where you can configure exactly what you're gonna send. Here's the TXRX driver. If you look on the help file, you're gonna find more details about this driver, but basically you use this driver to send, if I may say that, customized messages for your device. So you have a header, for instance, called TX, and I'm gonna send a message to a specific IP address. I don't even know which IP address I put here internally. Let's say I'm gonna go to this PLC here on the port number 502, and I'm gonna send a specific message that here I have my string tag with the message that I'm gonna send. So whenever I put here 1, whenever this tag changes, I'm gonna send a TX message to this PLC here. Okay? What if I want to receive messages? Well, you go here on the TXRX settings. You need to configure if you're gonna talk TCP/IP or serial. If you're gonna talk serial, here you enter the communication parameters. All right, we had a quick issue with the audio. Can you guys tell me if you can hear me again? Cool. Okay, I'm sorry about that. Just got disconnected. All right, so that's the thing about the TXRX driver. You configure if you want to have an end of text. So whatever I'm receiving, that's going to tell me that that's the end of the text. Or if I configure here on the TXRX settings, on the advanced, a timeout between characters, I can configure a header that when I'm receiving the bytes, whenever the time difference between those bytes is more than 500 milliseconds, I'm gonna assume that I have received all the messages. So that would be like, let's say ETX, or I can have a header called RX timeout. So whatever I receive, I put a tag here. Usually a string tag. That's the guy that's going to receive the message from the PLC. Okay, this driver, specifically TXRX, is quite helpful for reading barcode readers, RFID readers, or anything that you need to customize the message that you're sending to, and you're gonna have a response. And you can also have those values in hex, or they're gonna be ASCII. So if you put an H, you're gonna receive those values in hex formats, or if you don't put anything, it's gonna be pure ASCII messages. All right. But this driver here, I could have an entire webinar only about TXRX driver. You know, the amount of stuff that you can do when you know what you need to send to the device and what you're expecting to receive from it. All right. So let me read this. The other question. I have a question here. If the remote agent, this little guy here that's running here, I have a question asking if this guy on Windows C can run as a service. This is not related to the driver, but I'm gonna answer no. It's an application, so no, this guy cannot run as a service. Or we don't have a configuration for this to run as a service. Okay, if you go on Windows, you can configure any executable to run as a service. That's okay, you can do that, but we don't have a specific user interface to make the remote agent run as a service. All right, but you know what? That's a good suggestion. I have a question here about the ABCIP driver. The question is the ABCIP driver more efficient if you use structures, like it is more efficient using arrays? With the current driver, the answer is no. If you use the structures, we're still going to need to pass the whole name tag dot the structure member. That's how the protocol works. All right. The advantage about arrays is that I pass the tag name and then the initial position and the final position. All right. But on the upcoming version of this driver here, we're gonna have the option here to choose to create a tag database automatically. If I do this, we're gonna send a message to the PLC, and the PLC is gonna send us all the tags, and we're gonna talk only with the IDs. The communication is gonna be much faster. This driver is coming out in a couple of weeks. All right. So I have a question here. How many tags can be scanned on the main driver sheet? I have that number here on one of the slides when I compare the standard driver sheet with the main driver sheet. Just bear with me here because I don't know by heart if it's 4096 or 16,000. Just bear with me here. So it's 4096 tags per driver sheet. That's the question about how many tags can be scanned on the main driver sheet. All right. So it's 4096. I got a question here. If the code sys is compatible with version 6.1 of InduSoft Web Studio, yes. So when you download the driver from our website, you're gonna install it on 6.1. That's going to install also the other communication libraries that we need for that driver. But most importantly, you need to have the latest CodeSys PLC handler. We don't install that. Okay, you need to get that from 3S. Okay, we use the PLC handler, but who is gonna get you the PLC handler DLL? That's the API. It's gonna be 3S or your PLC vendor like Wago or ABB. You know, whoever uses CodeSys as the communication. All right, let me see other question. That's a good one. Has InduSoft a Siemens Profinet driver? The Profinet would speak with the S7-1200 PLCs. Our SAIF driver here. Let me add more communication drivers. Let me put the driver SAIF here. It talks with a 7-1200 as if it was any S7-300 PLC. You just put here the IP address 0:2 and the IO address as well. You don't put a tag name. You're gonna still need to put the memory address, but yes, it talks to the 7-1200 as well. All right. And I got another good question here. If there is a tool to make proprietary communication drivers, the answer is yes. We have our driver toolkit. The documentation for the driver toolkit is in our DVDs. If you have our DVDs, you're gonna see on the documentation part, on the documentation DVD, you're gonna see that we have the toolkits there. And that's a product that we sell, so you can write your own communication drivers if you need to. Okay, that's our driver toolkit product. Okay, I have here. Is there a document that lists the revision changes for the drivers? That's a good question as well. So when you open the driver help file, if you go to the very last page, we have here the revision history. So that's the first version, and then what we changed on that version. So this is a driver that is on the version 1.18. Whenever we release a newer driver version, we put what changed on that specific version and when the change was made, and even what was our engineer that worked on that modification. All right, so we got some questions here on the chat. Ideally the questions would come on the Q&A. All right, so let me see here. Are there available training videos on each of the drivers? For instance, the back-off TwinCat, we don't have specifically record the trainings for specific drivers, and actually that's a good idea. We should consider doing that for the most commonly used drivers. You have back-off here as an example, and we do have several customers that use back-off TwinCat runtime talking to InduSoft through ADS. That's a good suggestion. That's something we may consider doing videos for specific drivers. But on your case, for back-off TwinCat, you know what, man? That's the simplest of all the drivers. You just put here the TwinCat driver, for instance. You put the main driver sheet, and here you're gonna type the InduSoft tag. Let's say that the InduSoft tag that you have is the high flow alarm, and then you're gonna put the ADS net ID. For instance, 192.168.0.5.1.1, you know, and the runtime number or port number. Let's say 801 for TwinCat 2, or I guess it's 851 for TwinCat 3. You know, so that's, you know, your station field. And here the IO address, you're gonna put the variable name. If it's a global variable, you're gonna be dot and the variable name. If it's a local, you're gonna put, let's say, the POU name dot the variable name. Okay, on TwinCat 3 you may put, like, let's say application.plc1 POU name variable name. So it's very simple. And specifically for TwinCat, you may consider using our tag integration. I cannot do that while the driver is running. The tag integration here allows you to talk to TwinCat and CodeSys and Rockwell, and you point to a TPY file. So you point to a TPY file, you're gonna read the tag names directly into InduSoft Web Studio, and you configure also the AMS net ID. All right. But that's a good idea. We should consider specific drivers training videos. Okay, guys, I don't see any other questions right now. And I've passed way more than I expected, this being almost 1 hour and a half. And I really appreciate the attendance was very big. And let me show you guys here how to contact InduSoft for more questions that you may have. Getting back there on this slide. So how to contact InduSoft. Here you have our contact information. You have the emails for our office in the US, in Brazil, and in Germany. All the phone numbers, of course, for the US is +1. So we start here. We are in Austin, Texas, so area code 512. We have a toll-free 877 InduSoft. Here's our fax number. If you have questions, just send to support@indusoft.com. Technical questions. If you have general questions about anything about the product, just send to info@ one of those domains here, depending on your geographic location. Latin America, you can send to the US or to Brazil. If you're in Europe, you can send to Germany or to the US. Okay, just send us all the questions. We're gonna be more than happy to answer you. And a big thank you from everybody here at InduSoft. After this webinar, you're gonna receive an email with a link to a quick survey. We want to know what you guys thought about the webinar, so please, if you could respond that, we're gonna send you one of our t-shirts from our webinar series. All right, we're gonna be again this afternoon on the US afternoon here at 3 p.m. if you wanna come again. And thank you everybody for staying here, and have a great day, have a great evening, depending on where you are. Right, thank you very much. Bye.